Hello boys and girls, so in this video we are going to continue our discussion on 1.3 electric potential. Before this we already learned about the electric forces that exist between a pair of charges and also the electric field created by a point charge. So now we move on to what is electric potential. So class, electric potential we denote by E at a given point is defined as the work done by external force per unit charge to bring a test charge. Normally the test charge is a positive charge from infinity. Infinity means very far away, to a point in an electric field produced by a point charge. So it means that how we define electric potential V at a given point, first we must have a point charge. So this point charge will alter the surrounding space, become electric field. So when we have a point charge, there will be electric field produced. So this region will become electric field. So kawasannya ni akan jadi, kawasan di sekeliling point charge ni akan jadi electric field, medan elektrik. So any point inside electric field will have what we call electric potential V. So sebarang titik dalam medan elektrik akan mempunyai electric potential. So how we define electric potential at a particular point? So let's say teacher mark ni, this is the point, and I would like to know what is the electric potential at this particular point. So let's say this point is at distance r from the point charge Q. So how we find the electric potential at this given point? So it's equal to the work we need to done to bring a point charge from very far away, infinity, to this particular point, okay? So we have this. We might represent this equation, this sentence in the following equation. So the electric potential at a particular point, at a given point, is equal to the work we need to do to bring the charge from infinity to that point. Okay, so that point I represent by distance r lah. Divide by per unit charge. Per unit charge means divide by the magnitude of the test charge itself. Okay, bahagi dengan magnitude charge yang kita bawa ni lah, yang kita bawa ke point tersebut. Okay, so this is what we call electric potential. So electric potential is a scalar quantities. Scalar quantities means electric potential will not have direction. It's different from electric force and electric field strength. Force and field strength is vector quantities, but for electric potential is a scalar quantity, no direction. So if we refer to the definition, so the SI unit for electric potential will be joule per coulomb. Why? Because work done, work is joule. Charge is coulomb, so joule per coulomb, or we might express in volt, V, volt. Okay, normally kita guna SI unit volt lah. So SI unit for electric potential is volt. So class, electric potential V due to a point charge at any distance r, is given by V equal to KQ over R. Okay, V equal to KQ over R. So this is the equation we use to calculate the potential at any point P at a distance r, from a point charge. So K is the Coulomb constant, Q is the point charge that create the electric field, R is the distance from the point charge. So R is the distance from the point charge to point P at which the potential is evaluated. So remember, P is just a point in the space. P is not a charge, P is just a point in the space. Satu titik dalam medan elektrik kita. Then we have to bear in mind, not necessarily in one space we only have one point charge. So we might have electric potential due to several point charge. Kalau you ada lebih dari satu point charge, macam mana you nak kira electric potentialnya? Nah, contohnya, saya ada 2 point charge macam ni. How I'm going to calculate the total electric potential? So, when we have 2 or more charges are present, the total electric potential due to all the charges is obtained by we adding together the potential due to the individual charges. Ini maksudnya. Contohnya, dalam space ni kita ada 2 point charge, Q1 dan negative Q2. So, saya nak kira potential at point P. So, macam mana kita nak cari electric potential at point P? So, electric potential at point P akan sama dengan, will be equal to the potential because of Q1 due to Q1, saya label sebagai V1, plus the electric potential because of negative Q2, I denote by V2. Tambah terus, plus terus. Why? Because potential is a scalar quantity. It's a scalar quantity, so campur terus. So, apa formula untuk cari V? V adalah KQ over R. So, V1 will be K Q1 over R1. So, R1 will be the distance from Q1 to point P. So, this is R1. V2 will be K Q2 over R2. R2 will be the distance from Q2 to point P. This is R2. Okay. Then you notice that, teacher put negative for the charge Q2. So class, remember, for electric potential, in the calculation of electric potential, the negative sign of negative charge must be substituted in the related equation. So, ingat, kalau point charge you adalah charge negative, semasa anda membuat kiraan menggunakan equation electric potential, you have to include the minus sign of the charge in the substitution. Okay? Clear? Understood? So, I go through one example quickly to show you how I'm going to find the electric potential due to 2 charges. Okay, so I have point charge Q1, 5 microcoulomb, and also Q2, negative 2 microcoulomb. So, find the total electric potential due to these charges at a point P, whereby the point P is at the coordinate 0, 4. So, the point P is here. So, for point P, we are going to calculate the electric potential, and we understood the electric potential at point P will be due to charge Q1 and Q2. Then, electric potential is scalar quantity, so we just add directly lah, tambah terus, okay? tak ada arah, tak ada direction. So VP will be V1 plus V2. Algebraic sum. Algebraic sum means campur terus, tidak ada direction, scalar quantity. So we have VP will be V1 plus V2. So we have KQ1 over R1 plus KQ2 over R2. So Q1 is 5 microcoulomb. The distance of Q1 to point P is 4 meter. 4 meter. Okay, 4 meter. So this is R1. And then this is Q2. Q2 is negative 2 microcoulomb. And the distance from Q2 to point P is this one. This is R2. So using the theorem Pythagoras, so sini 4 meter, sini 3 meter. So R2 will be 5 meter lah, segi 3 tepat macam ni. So sini 4, sini 3, sini mesti 5 lah. Understood lah? So class, we put in the value, so we will get the electric potential P will be 7,650 volt. Okay, so this is how we calculate the total electric potential at a given point. So class, we move on to another concept. So in between charges, we learned it before, in between charges, they have electric force exists between two charges. Actually, beside electric force, in between two charges, they might have what we call electric potential energy. So in between a pair of point charge, they will have electric potential energy. We denote by capital U. Okay, so how we calculate the electric potential energy between a pair of point charge? So let's say I have charge Q1 and Q2. They are separate by a distance R. So the electric potential energy associated with these 2 point charge is given by K Q1 Q2 over R. Okay, so K is the Coulomb constant, Q1 is the charge 1, Q2 is referred to charge 2, R is the distance between the two charges. Okay, and then bear in mind energy. So like recall what we learned in Sem 1, energy is a scalar quantity. So electric potential energy is a scalar quantities, no directions. No directions, tak ada arah, scalar quantity, ada magnitude sahaja. The SI unit will be joule lah, understood lah, because it's energy. Energy is joule. Again, I remind you how we are going to distinguish the charge is positive or negative. So when we do calculation using this equation, the negative sign of negative charge must be substituted in the equation. Okay, when we do calculation, we have to put in the negative sign for negative charge. So ini maksudnya, if Q1 is negative, what we need to do when we apply this equation, we have to put in the negative sign. Okay, see, we have to include the negative sign when we do the substitution, bila kita buat penggantian nilai. Okay, jelas Then class, we not necessarily only have a pair of charge in the electric field. So if we have a system of point charges, let's say 3 point charges. Let's say I have 3 point charges. I have Q1, Q2, Q3. Distance between Q1 and Q2 is I denote by R12. Distance between Q1 and Q3 I denote by R13. Distance between Q2 and Q3 I denote by R23. So each pair of these charges will have electric potential energy. So how I calculate the total electric potential energy of this system of point charge? So the total electric potential energy U of this system of point charges will be potential energy between charge 1 and 2 plus the potential energy between charge 1 and 3 plus with the potential energy between charge 2 and 3. Okay? Plus campur terus. Kenapa campur terus? Sebab energy adalah scalar quantity. Okay? Dan kita letakkan equation lah. So how you find U12? It must be K Q1 Q2 over distance between charge 1 and 2. Same go for U13. It will be KQ1 Q3 over R13 and U23 will be KQ2 Q3 over R23. So this is the equation to calculate the electric potential energy for a system of point charges. Okay? But for your matriculation level, we just focus or we just limit to a maximum of 3 point charges lah. So kita limitkan lah, maximum charges kita adalah 3 sahajalah untuk matriculation level ah. So again, I remind you, you have to include the sign of charge. Let's say if Q2 is negative charge, remember, you must substitute the minus sign into the equation lah. Kena gantikan negatif untuk Q2 lah. Kalau Q2 adalah charge negatif contohnya. Okay? So, teacher tunjukkan satu contoh kiraan. Let's say I have 3 point charge macam ni. Q1 is 2 microcoulomb. Q2 is negative 6 microcoulomb, Q3 is 3 microcoulomb, and this is the separation between the charges. So how I'm going to calculate the total electric potential energy for the system of charges? So take out the equation. So I will add up the potential in between 1, 2 plus electric potential between charges 1 and 3 plus with the electric potential between charge 2 and 3. Okay, then we put in the value. Okay, so ingat Q2 adalah negative, charge negative. So charge negative, so masukkan tanda negative. Okay, so include negative sign for negative charge. Then if you do the calculation correctly using calculator, you will get the answer for electric potential energy for the system of charge will be negative 5.49 to the power of negative 2 joule. Okay, so this is how we do calculation for a system of point charge in order to get the total electric potential energy. Clear? Understood?